Hello everyone, I am Mohammed Abdul Haseeb, and as part of the course Strategic Management of Information Technology, I will be presenting a detailed analysis of the article Machine Learning for Enterprises, Applications, Algorithm Selection, and Challenges. This article is authored by In Lee and Yong Jishin. Outlining the agenda of the presentation, firstly I will give a brief introduction of what actually is machine learning, what is its primary goal, and why enterprises are increasingly turning towards machine learning. Then, I will highlight the relationship between artificial intelligence, machine learning, and deep learning, followed by a discussion on the categories of machine learning. I will then show how the article presents us with the applications of machine learning at the enterprises. After that, I will present various machine learning selection criteria and how to choose the right machine learning algorithm. Post this, I will give an overview of how machine learning is being deployed in the financial services. And then I will shed some light on the challenges to deploy machine learning in the businesses. Finally, I will present the relevance of machine learning to this course, evaluation of this article, and conclude the presentation. Machine learning is a field of artificial intelligence that focuses on developing algorithms and models that enable computers to learn from the data and then make predictions and decisions without being explicitly programmed. The primary goal of machine learning is to allow systems to automatically learn and improve from experience, iteratively refining their performance over time. The rise of machine learning in the present can be attributed to convergence of several factors such as increased computational power, big data, improved research on algorithms and models, competitive advantage, enhanced decision making, and requirement for automation and efficiency. As we navigate the intersection of technology and business, this article explores the transformative impact of machine learning on enterprises and serves as a guide for enterprises who seek to harness power of machine learning to navigate the complexities of modern marketplace. Now, coming to the difference between the concept of artificial intelligence, machine learning, and deep learning. Artificial intelligence refers to a broader concept of machines or systems exhibiting intelligence comparable to human intelligence. Machine learning is a subset of AI that has algorithms and models that learn from data to make predictions or decisions. Deep learning is a specialized and advanced subset of machine learning that is about training computer systems to learn and make decisions in a way that somewhat mimics how humans learn and process information. Coming to the categories of machine learning, the first one is supervised, where the models are trained on labeled data, making predictions or classification based on the previous examples. Unsupervised learning models are trained on unlabeled data, finding patterns or structures without any explicit guidance. In the semi supervised learning, it is a combination of both supervised and unsupervised learning. It is useful when the labeled data is expensive or time consuming. Reinforcement learning. In this, the agents learn through interaction with the environment, receiving feedback in the form of rewards or penalties. Enterprises use machine learning for three main purposes, which is clustering, classification, and prediction. Clustering is an unsupervised learning task where algorithm groups similar data points together based on inherent patterns or similarities. Classification is a type of supervised learning where algorithm is trained on a labeled dataset to categorize input data into predefined classes or categories. Whereas prediction involves estimating a continuous output variable based on input features. Examples are sales forecasting or stock price prediction. With a wide range of machine learning algorithms available, managers find it difficult to select the best ones to solve their problem. One big challenge in choosing the best algorithm is managing the trade off between accuracy and interpretability. If you choose accuracy focused models, you get better prediction and classification. You can also capture the integrate patterns in the data. But the downside here is it is hard to understand how model has arrived at a prediction. Whereas if you choose interpretability focused models, you will get clear insights which are very easy to understand and thereby offering a better help in decision making. The downside here is we cannot capture the complex relationships in the data. The choice between the accuracy and interpretability in machine learning algorithm selection depends on the specific requirements and constraints of the problem at hand, as well as it depends on the priorities of the organization or the project. There is a trade-off between accuracy and interpretability of a model for two reasons. By adding more parameters, model's accuracy increases, but the outcomes are harder to understand and interpret. Secondly, there are certain assumptions about data and model functions that help in interpretation of the outcomes, but highly accurate models have no or little assumptions. The choice between accuracy and interpretability in machine learning algorithm selection depends on specific requirements and constraints of the problem at hand, as well as the priorities of the organization and the project. The various factors for choosing between accuracy and interpretability include nature of the problem, stakeholder requirements, regulatory compliance, the characteristics of the data, the model complexity tolerance, and ethical and social implications. The article presents the process to choose the right machine learning algorithm. At first, we collect the data and then prepare or clean it. Then we check if the data has output variables or not. If there are no output variables, then we evaluate all the unsupervised machine learning algorithms and choose the best model. If the data has output variables, then we check if the interpretability is required or not. If the interpretability is required, then we evaluate all the interpretable supervised machine learning algorithms and choose the best one. If the interpretability is not required, we evaluate all the supervised machine learning algorithms and choose the model with highest accuracy. There are three cases of machine learning applications in the financial services industry highlighted in the article. Allstate. Allstate is a widely known property and casualty insurer. Allstate deployed an machine learning based interactive solution Emilia that helps customer support representatives answer the clients more effectively. It uses NLP, machine learning, and data analytics to generate and store possible solutions to customer problems by learning from listening to client conversations. It has found to reduce client call duration and increased first call success rates. ING. ING is a Dutch multinational bank. It has deployed ML-based chatbots to handle customer requests. It also uses machine learning algorithms in credit risk management and bond trading. It has partnered with Google and PwC to make an early warning system that helps credit risk analysts to make quick and informed decisions if customers are exposed to any potential risk. Mizuho. Mizuho is one of the largest financial services companies in Japan. It has deployed machine learning models to predict market conditions. These models help in identifying warning signs of market volatility. Partnering with IBM, it has developed an advanced ML based forecasting system called IBM. IBM is helping the company in asset liability management and treasury portfolio operations. There are four main challenges of deploying machine learning at the enterprises. The ethical challenge. Machine learning may use sensitive data from the healthcare or financial domains. Any biases in the data can lead to biased models. The data quality challenge. Any inaccurate or incomplete data can result in models that make unreliable predictions or reinforce existing biases. Shortage of machine learning engineers. There is an acute shortage of engineers with expertise to develop, deploy, and maintain the machine learning models. Cost benefit challenge. The deployment of machine learning models involves significant upfront costs, including data collection, model development, and infrastructure setup. This article on machine learning is highly relevant to the course Strategic Management of Information Technology. It lays down a foundation of how integrating machine learning into IT can contribute to competitive advantage in today's technologically driven business landscape. Understanding and integrating machine learning concepts can enhance the strategic capabilities of IT management in modern business environment. IT management can leverage automation to improve efficiency and streamline their operations. It can also help organizations to allocate resources more effectively. It can also allow organizations to align their IT strategies with a more data centric perspective. With its predictive capabilities, it can help identify patterns that can contribute to better decision making. Finally, machine learning driven cybersecurity tools enhance an organization's ability to identify and respond to security threats. Coming to the analysis of the article, for the upsides first, the article presents an in depth understanding of the topic of machine learning. The theme of the article is very relevant and future focused. There are also real life application examples highlighted in the article which help in better understanding of how and where machine learning can be deployed. Finally, it also serves as a guide to explore the power of machine learning in transforming businesses. Now, moving on to the downsides, the article could have shed some better light on the future prospects of machine learning and solutions to overcome the challenges highlighted in the case. Some topics, due to very technical nature, require some prior knowledge, and more attention could have been given to explaining the concept of deep learning. In conclusion, the integration of machine learning into enterprises represents a transformative journey into the data-driven future. In future, some of areas which will increasingly deploy machine learning are edge computing, where the data will be processed close to source rather than in a centralized cloud. Machine learning algorithms will be deployed for automation and efficiency improvement in the IT industry. Management will extract insights from the data and make informed decisions. A personalized user experience with recommendations, interfaces, and systems will lead to improved customer satisfaction. Integrating machine learning for enterprises is not just a technological upgrade, but it's a paradigm shift that defines the future of how organizations operate, compete, and thrive in this new era of business excellence. Thank you very much for listening.